Hello. In this video, I want to talk a little bit about synchronous, asynchronous, and event-driven code in JavaScript. So I'm running Node version 22.8, and I'm just going to serve a basic index.html, and I'll put HTML5 in here. Just have a basic document here, and the body can have a button in it with the ID of do btn, and it'll just say do to do a task, do task. Then if I want to use some JavaScript here, first I'll just serve this so you can see what it looks like. I'll use the live server package from npm and just use npx to execute that. So this is going to have a do task button, and then what I can add here is a script. For some reason this is getting confused and thinking the page is in Arabic, so I'm going to say that the page is not in Arabic. Not sure what's going on there, but we'll say the do button is get element by ID do button, and then it's going to add an event listener on the click event when we click this, and it'll do the task. And so to do that, I'll just have it say done on the button label when the task is done. So we'll say do button dot inner HTML is done. So this will obviously only work once, but I can click the button and it'll go to done. When the page loads, it'll be do task, I'll click it and it'll say done. So what's happening here is that the body is getting set up, and then this script is being registered after, and it's able to access the document. Now if I move this script above the body, you'll see that this is not going to work as nicely. So if I click do task, nothing's going to happen, and the reason, if you check the console with F12, is that add event listener doesn't exist on do button because do button is undefined, because document.get element by ID returned nothing. And that's because the document was set up later. So this code is being evaluated, this HTML markup is being evaluated top to bottom. And so the script can't be before the body unless it is a deferred script. So you can have the defer keyword here, except defer will not work for inline scripts like this. This will only work for scripts that are imported from a JavaScript file. So if I say index.mjs to point out that it's a module, and then I move my script code to the MJS file, and then I import that as src, is going to be index.js script, and the type is going to be module, just because I want it to be a module. So I'm going to make it MJS to make that extra clear. And then if I reload the page, we'll see that do task will now work, because we have this defer keyword that says wait to execute this script until the whole HTML body has been set up. And so already you can see how it's important when things happen. Things happen in order synchronously when this file is evaluated, and so it matters whether the script tag is above or below the body. Now, if you look at our JavaScript code, you also see there's another thing going on with respect to asynchronous code, and what we have here is actually a combination of synchronous and asynchronous code. So our script file runs from top to bottom. It does line 1 and then lines 2 through 4, and then it would get to line 5. But add event listener is not actually executing this function in here. It's simply setting it up. So to make that clearer, I could pull this out and say const callback is what you would call this, a function that gets called back after things are done. So I'll say callback is equal to this anonymous kind of arrow function. It has no name yet on the right side of the equal sign. And then on click, I want to run callback. Now, if I simply were to, let's say we do done, and then we'll add a unique ID. So I'll just do like done dash $, curly braces, and we'll do the global this dot crypto library, the built-in crypto library, and we'll just get UUID, a random UUID. So that'll be a unique ID, and every time we click that button, we'll get a different unique ID. So if we run, if we're passing this callback in properly, it's going to pass, actually the event listener, add event listener is going to set it up so that every time the click is done, an event is passed through to the callback. So really this would have an event passed into it. And so if you console.log event is and E, then you'd see that the event is that. Whereas if you were to just call this callback like this, obviously you're not passing in E, so event is undefined. And the other thing that happens here is you notice as soon as I load the page, the callback gets called, because as this JavaScript is executing on line 6, callback gets called. Whereas when we just pass in the name of the function, then callback isn't actually called now. Callback is only called when that click event happens at some point in the future, and then every time it happens at some point in the future. So this is an event-driven architecture, and this is an asynchronous callback in the sense that this callback doesn't actually run when we provide it. We define it here, we provide it here, but it's actually only run when the click happens. So that's a very important paradigm here, is that even though this code is written above this code, it doesn't necessarily mean that the stuff inside of here is happening above the stuff that happens down here, because it may be only triggered by an event or a function call. You know, you can think about the same concept is if you were to just run the callback like this, you know, you run the function and it will change that value. If you just define the function but you don't run it, it never actually happens. So we've defined a callback but it hasn't happened. So that's an important difference of defining a function versus actually using those parentheses to call a function. And so here we're just setting things up. We're not actually doing the call, then we click and it does the call. Now this is a common technique for doing things asynchronously, where you want to say when something is done, I want you to run this function. So a common thing that you would have to wait for would be network activity. So for example, you're making a fetch request and you have to wait for the fetch request to come back before you can do something. So maybe you have some like result area, like a paragraph. So P result, and inside of that P result, you're going to put some results from a fetch request. So let's say we use a public API like the JSON placeholder, and we use some fake API from them that's on the real internet. So this would be an example of getting a bunch of to-do data. You could get a single to-do item. So let's say you just want to put this this JavaScript into your HTML. You could do something like a fetch call, like they have the code for right here. Fetch is built into JavaScript, and you'll see this what's called promise chaining, where you have .then on the fetch. And the reason is because what fetch returns is not actually the object itself like you see here. It's actually a promise, what's called a promise. So you'll see that if you hover over this, it returns a promise for a response. So it doesn't actually return this response itself directly, it returns a promise. So what does that mean? It means it's something that isn't going to come until maybe a little bit later, but this code, because it knows there's a potential for a latency, it wants to give back control over to your code so that you can do other stuff and just worry about what happens after this finishes asynchronously, meaning not at the time that this line of code is running. So let's see that a little bit in action. So our callback function, remember, just like changes the text of this button. So I'll just run the callback function here, And so I'm also going to register that. So initially it's going to just say, we'll just put that UUID in there when this loads, and then every time we click it, it'll change. So what fetch can do is get this data, and so said const promise is the result of fetch, or really it would be like a response promise. You'll see that if you were to console.log that, you'll get the console.log very quickly, regardless of how long the request takes. So let's say you console.log. Like this. So the promise is a pending promise, and then when you click on it, it now says fulfilled because it probably got fulfilled shortly thereafter. And you don't actually see the data. So to get the data, you have to do either that promise chaining or you have to do async await. Now, typically you couldn't do async await on the top level of a file that's changing, and in modules you can now do that in certain versions of JavaScript, but the typical way would have been to do promise chaining, where you do a dot then on the promise that says after this promise is resolved or rejected, meaning it failed, then we do something after that. But the advantage is that our code can continue to run even though this promise isn't necessarily ready yet. We can continue to do other stuff like set up these click handlers and things. So how do we actually get this data? Well, you saw the dot then, but I want to simulate for you this taking a little bit longer than it might actually take, because this might be very quick to occur. So for example, if you were to say response promise dot then, what's going to happen is if that resolves, it's going to give you, there's two things that a promise can do. It can resolve or reject. So resolve is like it succeeded and the value came through, and rejected is like some kind of error happened. So you typically, in the promise chaining approach, you get the result of that with then, and then you pass in a callback function. So callback function, think like this callback down here, where we say when a click happens, I want you to run this callback. This says when this promise resolves, which we don't know when that might happen. When that happens, I want you to run this callback. So take in that value inside, so the promise interior value, which in this case, if you hover, fetch was supposed to have a response, so a good name for that would be the response. Then when you get a response, I want you to do something with that response, and in this case, maybe I want you to just console.log the response. So the response is this, and so you get a response object with a bunch of things. And to actually get that turned into JSON, you need to run the JSON function. So this will return response.json, which in turn is going to return a promise as well. So now this stage, this then, has now returned a new promise. So now we have something else we have to wait for to be done. And so this is what promise chaining allows you to do. It's a chain because this is the first link, this is the second link, and now we can actually do another then, and now the then is the thing returned from the previous part of the chain. So this part of the chain returns a promise to some JSON. So we will say .then takes some JSON and, for example, console log that JSON, and we can stop logging the response if we want. So now once that JSON once that response comes through, it gets turned to JSON. Once that JSON is ready, then that gets console logged. And so it happens very quickly, as you can see. but occasionally this could take longer for different reasons. And what's important to note about this time delay, the time delay doesn't really have to do with computation happening on the user's device, so on the browser. The browser is not being slow in computing what this data looks like. What's slow is the speed of light between the server that JSON placeholder has and our computer. There's a lot of wires and radio signals that have to go through, and it might have to travel across the world, and so that takes a time delay. Or the servers may have a built up a queue of different requests, and you may be at the back of the list or back of the queue, and so you may have to wait for your turn, and so your request could take longer. So we can simulate time delays with a built-in function to JavaScript called setTimeout. There's also setInterval, which can execute a callback function at a specified interval, but timeout will just wait, and after a certain number of milliseconds, it will just run a particular function. So you'll say when we reload this, after 3 seconds, the JSON gets printed again. And the other thing that we can do here is essentially to say when you get the JSON, you can return a promise that wraps this particular set timeout. So this is a decent time to start talking about async await, and we'll come back to this data here, but just know that for now, inside of this callback function, we have the response JSON, and it has the title and the ID and the user ID of this to-do item that came from this API. So now let's talk about set timeout and promises. So set timeout is just a random example of a built-in that you can easily create something that takes a time delay, because it is literally a timeout function, and you'll see it returns a number. So it's not an asynchronous function itself. It's completely synchronous, but what it does is that it doesn't actually run this callback function until after that timer has expired. So if you say console.log, 3 seconds have passed. Let's move it down to 1 second so it's faster to see, but after 1 second, then it's going to actually run that function. So set timeout runs, the code gets to keep going. We do all our other stuff, like I can run this, click the button as many times as I want, and then after a second, then that's going to come in. And I was still able to interact with the page and do everything because the rest of my JavaScript got to run right after this happened, this other stuff happened. So there was no blocking here. The JavaScript was not blocked. I'm trying to do this. Now, if I wanted this to be inside of a promise, I would have to actually create a promise and make sure that the promise only resolves once this interior callback function happens. So while the fact that we're using set timeout here is kind of arbitrary, the fact that we're wrapping it in a promise is something that you might do more often to actually convert synchronous code with a callback to an asynchronous function. So an asynchronous function would be one, instead of function sync a like this, an asynchronous function, so return 1, for example. An asynchronous function would be with the async keyword, function async a, and it could also return 1. And so it looks like this is returning a number, but if you hover over the function, you'll see it's actually returning a promise with the generic type of a number. So the intended result is a number. So the result that is actually returned from this function is technically of the type promise, and it contains a number once it resolves. So it's confusing because it's a wrapper for the data. Now the sync a, by comparison, simply returns a number. So you'll see promises are automatically created by async functions, but you can also create them manually. So the way that you do that is with more callbacks. So you can create a const p or prom or whatever equals new promise. So use the built-in promise constructor, and that's going to take a callback. Different callbacks you can provide, but you see resolve and reject and those should be functions that take a value or a reason for the rejection. So a value would be the, say in the case of this, the number that you want to return would be the number you would resolve, and then rejecting would be the reason, i.e. an error that you had caught inside of your code. So you would usually take these and you can name them whatever you want, like res and reg, for example. You take those, and inside of your callback, then you'll do whatever you're going to do. And this could be synchronous code. And then whenever that synchronous code encounters something that it wants to return as the value of the promise, then you just simply call res with the value that you want to return. So may be confusing, but it'll start to make sense as you do it more. So let's say you have set timeout. This doesn't return a promise, so we need to wrap it in a promise. So we create a new promise and we say this promise should only resolve when 1 seconds have passed. So we'll say res1. This would be the same as an asynchronous function that returns 1 after a second. So then I could say console.log prom is, and you'll see that prom is a promise that is pending. And so that's because we haven't waited for this promise to be done. But just like the fetch promise, we can do a then on that. And so we could say prom.then result console.log result is result. And what you'll see is that it takes a second, then the result comes through, result is 1. And there you can see where the delay is actually having an effect on when that gets printed. Since we're not printing this synchronously, we're actually printing it asynchronously. Only once 3 seconds have elapsed and this set timeout function runs does it call this resolve, which allows the promise to resolve, which causes the then to get triggered, which runs this callback. While it seems overly convoluted, we're both the producer of this promise and the consumer. Normally you would just be one or the other of those, or you might be one of those and then somewhere else in your code you might be the other. So in the case of like your fetch request, you're not actually creating the promise, you're just using the promise that is given by fetch. So in this case, let's say we want to make a little async function that causes a delay. This is something that you'll do when you want to have a nice async await for waiting an amount of time. So you say you want to wait a number of milliseconds, and then you can create a new promise and you'll return that promise. So you'll say return new promise, and you could say set timeout, and it will simply resolve after, we don't need 2 returns, it'll simply resolve after the specified number of milliseconds. So wait milliseconds. That will delay and then resolve with no value. We don't really care about the value. We could return milliseconds if we want. And that would be a nice way to have a promise created for a number of milliseconds. So why I'm doing that is to create a little fake delay for our fetch request. So I said we would come back to the fetch request. So we have JSON, and so let's just say we're going to return wait 200, then return that JSON, that original JSON. So again, we're doing another then, but we're just saying don't let this JSON get passed to the next step until we have waited 200 milliseconds. So .then JSON console.log. Obviously this is not needed to do this. It's just something that I did to create an extra long delay for this data coming in from this API. You know, something that could really happen in your application is that data could be nice and slow. So if you're depending on that data being ready and it's not actually ready, that would be a problem. So your code can continue to run even though this is here. Like you can clearly see if I console.log, script is done, let's say done executing. You'll see script is done executing right here, and then the JSON comes in later. So all this stuff has happened, and because these actions are happening asynchronously and not synchronously, they don't actually happen until these different things occur. And so the important thing here is that this might be confusing how this is returning wait.then. Just remember that then takes something which is a promise and it returns another promise. So this is just returning a promise, and since we're in a then returns a promise, and so that allows us to get the value at the next step in the chain. And personally, I find that promise chaining can get quite messy, and so that's why oftentimes asynchronous functions can be better ways to manage the complexity of multi-step promise chaining. So for example, let's say you want to async function get to do, and that's going to, let's say, take the ID that you want to get, and so your URL would be const URL is to do / that ID, and then you can a response would be await fetch. So fetch is going to return a promise. Awaiting the fetch will actually pause the code inside the async function and let other things happen throughout your application. Come back to this only when this promise resolves. So it's a convenience over having to do that .then. We can instead do a await, and then we can just get the actual value rather than a promise to the value. Await will strip off the promise part of this and just give us the actual value. Now there could be an error, in which case we would want to catch that with like a try catch block or something, but I'm not going to focus on that here. So then we can do our next step of our promise chain, which is to await the response.json of that. Then let's say we wanted to wait 2,000 milliseconds, and then we want our function to return the JSON value. So get to do is going to return, you see, a promise, and that's because it's an async function. So it has to be able to return immediately after all this is set up. It needs to be able to return immediately, but then things might happen later on. And so this is a nice way to essentially replace all of this right here in a little bit of a simpler way. And then all you need to do is set up whatever you're going to do after this data comes in. And for that, because most code is synchronous, you're going to oftentimes need to use at least one then in your code to make something happen synchronously. Or what you might also do is kick off an asynchronous function but never await the value. So if you wanted to, for example, if you put a top level await, which is not allowed in all kinds of JavaScript, but in some JavaScript it is, you said await like const to do equals await get to do 1, the ID of 1. You'll see that the script is not going to get done executing until that to do resolves. So you're going to block the execution of this thread with that await, and that is oftentimes not what you want. And so you might rather to say that you would get to do and then then do something like stringify the to do. Or you might even do that here. Let's say return JSON.stringify the JSON tool, and then stringify that JSON. And then you might want to take this thing and then put it to your result paragraph. So document.getElement by ID result .inner HTML equals to do. And then when that data comes through, it'll put it into the paragraph. Meanwhile, your code doesn't get stopped up, and you can continue to, for example, you can set up your button so that you can use your button while you're waiting for your data to come in. If you use top level await, which by the way is not available everywhere, this is only because the module code and this is modern JavaScript, you would have the disadvantage that if you were awaiting this, because remember, .then will return a promise as well. So we can easily just as await get to do .then as we can to await get to do. So if we load this now, we don't have the button doing what it's supposed to do until that stuff comes in. So it makes much more sense to do something like this, where we have that happen asynchronously. And so essentially only does this callback in here run when this promise has resolved, and that takes all of these asynchronous steps. We need to await the fetch to happen. We need to await the JSON to get translated. We need to await the timeout to happen, and then we need to return this synchronously finally. And another thing to point out is that you can create an async function that has no async actions inside of it, but that would be a little silly. So if you never call await inside of an async function, or you don't return a value, like if we just directly return fetch of URL, then this would make sense too, because this returns a promise, so we're returning a promise. But you would never just return like URL inside of the async function, because then you would be unnecessarily wrapping this URL in a promise when it could just as easily happen asynchronously. It doesn't make any sense. Also, another point is that returning fetch is the same as return await fetch. It's the same thing in most cases, because this is a promise and you're going to be awaiting whatever the result of this is. So this is just saying, wait for this to be done before you return this value, which is ultimately going to be waited for by someone else. So I like to use the await keyword explicitly, but in this case it's not strictly necessary. So that's been a little bit of a primer on event-driven and asynchronous code. A lot to kind of keep in your mind, but some of the important things are that your code is going to run from top to bottom. So when your HTML is evaluated, you need the defer keyword and a script, an external script, if you want to put your script before your body. Otherwise, if you have an inline script, it's always going to need to go after the body. And then in your code, you can do synchronous actions in your code, and then you can use callback functions to have other things happen based on events. So in the case of a button, a click event will trigger some code to happen. Even though you've defined that code above where you register that code, and no one calls this code here, it does get called eventually by an event that happens in the browser. Then you have asynchronous code that functions using a combination of callbacks and promise chaining, like this, like the .then keyword on a promise. And you also have the async await syntax. So the async await is an alternative to the promise chaining, which can work in a synchronous setting. You can use top level await to wait for some promise to be resolved inside of your synchronous code in certain module codes. So this is an MJS file with type module when it was put in the HTML. In CommonJS without module, this would not be okay to do. And it also is going to have the downside that it's going to block your code from continuing to execute until that promise gets resolved. So you often want things to happen according to a callback like this, although it may be easier by creating async functions that you can more step by step and more easily closer to the left line, which is the left side of your file, which is always preferable to me to keep things readable. You can explicitly keep each of your steps in line, and then emphasize when you're waiting for something that's asynchronous to be done. And the big thing about async functions is that they return promises and not values themselves. So like things like the fetch API that's built in are going to return a promise, and you have to either await that promise or you have to .then that promise. When you await the promise, you get the value out on the other side. When you .then the promise, you pass a callback that can receive the value as its parameter. .then will also return a promise itself, so you can chain lots of promises and then you can await that entire chain, or you can .then that entire chain. And finally, you can create your own promises for code that happens using callbacks but is synchronous. So again, the set timeout function is an example of a synchronous function that runs a callback asynchronously, but itself it does not return a promise. So if you want it to be async awaitable, you need to actually wrap it in a promise, which is an object you can create by passing it a callback to a resolver function and a rejector function. The resolver function runs on the happy path if the value comes through at some point asynchronously, and the reject is called if some sort of error occurs on the non-happy path, also asynchronously, so that the caller can, or the user of this promise, or the caller of this async function in this case, can be able to handle that error and catch it. So it's a lot of information, but these concepts are the core of event-driven and asynchronous programming. And if you don't understand the fact that code can be defined, but then not necessarily run when you see it defined, it's going to create a lot of confusion, because defining functions and setting up event handlers and callback functions is going to be a huge part of what you do in your JavaScript programming to create user interactions and deal with network data. So just to only have the skill to be able to create scripts that execute synchronously from top to bottom is going to leave out a lot of important value that you can add as a JavaScript programmer. So thank you for listening and watching. That's going to wrap it up for this video.